Hello everyone, my name is Satyakam Pratap Singh and welcome to this TA session for Probability Foundation for Electrical Engineering. This is the first tutorial, and in this tutorial we are not covering the in-depth probability of this particular course, but we are giving some of the glimpse related to that which can help to solve the few of the assignments. And this course instructor is Professor Krishna Jagannathan sir from IIT Madras, and I am Satyavikram Pratap Singh from IIT Bombay, a PMRF research scholar. Okay, so starting with the tutorial session. So here the structure will be such that I will give you the few of the problems. You have to solve that, and if you face any problem in between, just let me know. Okay, after giving the few minutes of time, after that I will solve that problem and give you some glimpse that how to approach that problem. Okay, so this is actually the first problem. This is actually the assignment 0 problems. Okay, so this is the first question of that assignment 0. So you can see that and get to know that what actually how to solve this problem. If you are facing any problem, just let me know. Okay, I will give you the solution and few of the glimpse that how to approach that problem. First thing I need that you should first try that. Okay, let me give the solution for the first problem. Here in this question, if you see, there are few terminologies are there. Okay, so if you see there here, the let xn will be such that n belongs to n be a sequence of the real number such that mod of xn is less than or equal to k for each n belong to n. Okay, where k is given as a finite positive constant, you have to find out the what is the limit when n tends to infinity of the xn. Okay, so in this problem, if you see, first important thing is what is actually the natural number is. Okay, real number is basically when you see the all the numbers which actually appears on the number line. On the number line is real number. Okay, and it can be such that it can be a rational or it can be a irrational number as well, rational or irrational as well. Okay, So what is saying that ki it is less than this value mod of xn should be less than or equal to k. It means that suppose xn is greater than 0. So it means that ki xn will be less than or equal to k. That is fine. Second case will be such that if xn is equal to 0, okay, it means that 0 is less than or equal to k. Okay. C case is such that xn will be less than 0. In this case, minus of xn will be less than or equal to k, or you can say that xn is greater than or equal to k. Okay. So what is it is meaning that? Okay. It means that it is actually a bounded system in on the x-axis line such that its values lie, suppose the xn is 0, the value will lie here. Let me take another pen. The value will lie here. If xn is greater than 0, it means that it will be less than or equal to k. K is positive constant, finite positive constant, so it will be lie here. Suppose it is lying here. Okay. If xn is 0, the k will be such that it will be 0 less than or equal to k. It means we greater than 0. It will lie here. If xn is less than 0, it means that it will be greater or equal to minus k here. So suppose this is a minus k. So where the actually the x lies? X actually lies here. Okay. This is a part of the xn. So what is the actually the solution of this limit n tends to let me take the another slide for that. New slide. Okay. What it is mean that xn is lying between xn is lying between minus k to k. It means this region basically. Okay. What is asking that what is the value of limit when n tends to infinity. Erase this. When n tends to infinity, the value of xn. Okay. Suppose when xn is equal to 0, okay, its value will be equal to 0 only. Okay. So this limit will be come out to be 0. Okay. But when limit n tends to infinity, xn, and xn is some positive number, okay, lying the right side of the right side of the y-axis. Okay. It means that it will be when it tends to infinity, it will closely related to the this k positive constant, so its value will be come out to be k. Okay. So in this, if you see the options, option A is actually k, B is a finite constant. When it is value is a k, so it means that it will be a finite constant. Okay, either one, either two, or it should be a constant. C is also possible when the xn is 0. Okay, so what will be the correct answer? None of these. None of these is the correct answer for this problem. Okay, any doubt in this? So basic means is basic terminology of that problem is that you should be very focused on the terminologies. First is the what is the real number. Real number is all the numbers which lies on the this number line is called as real numbers. Either it can be a rational or irrational number. When it is saying that mod of xn is less than or equal to k, it means that there are three possibilities can be there on the xy plane, on the 2D plane. Okay. If xn is greater than 0, it means that xn should be less than or equal to k, because k is a finite positive constant. Second, if a xn is 0, then the k value will be actually equal to 0. Okay. Why? Because it is saying that k should be greater than or equal to 0. It can be 0 or greater than 0. Okay. Third thing is that if it is less than 0, it means that minus xn is less than or equal to k, or xn is greater or equal to minus k. So there will be a bounded region in between this xn can be existent possible, that is in between the minus k to k including 0. Okay. When you are seeing that how it is actually approaching to the infinity side, that n tends to infinity, so it's basically approaching to the value of k. So the correct answer is the k. Okay, so that is very important to learn. Basic definition that k, how this limit notation can be seen. Okay, uh, if you see this function fx on a y-axis and x on this x-axis, the limit x tends to a fx. Suppose this is the value where this function, this is the fx f graph, and this is the y plane. Okay, so this x tends to a fx. It can be approached from the downward side also, it can approach from the upward side also. That is being called as the left hand limit or the right hand limit. That is the thing. And second part is that ki if it is approaching the to the a, x is approaching to the a, then fx will approach to l, this point. Okay, what does mean that? It means that ki when x get arbitrarily close to a from the both sides, the value of fx get arbitrarily close to l. Okay, suppose let's take a function. Suppose I'm taking a function like this. Suppose a function like this and it drops to 0 here. Okay, then it moves forward and then moves like this. Okay, our main, suppose I wanted to find out the, suppose I wanted to find out the value of limit. Suppose this is fx and this is the function f. I wanted to find out limit x tends to a fx. But when you approach this point, the approach of the f will be such that this will be the value. Okay. But when you move from the right side, suppose I'm moving from the right side from here, the y towards the a, the value if you see from the this side, it will be actually moving towards the this side. Okay, but even when you see that ki, actually at the previous movement of the a, the values are totally different as compared to the when you are moving from the right hand side. Suppose you see these points. Okay, so it's a kind of, you can judge that ki whether it is a continuity is being maintained or not. Continuity is being maintained means you are having a finite constant from the left side as well, right side as well. So the continuity will be maintained. Okay. So in that sense, two types of this two-sided limits can be defined. That is left hand limit when the value fx approaches as x, okay, from the left side, or the right side when it is approaching to the fx, so it will be considered a minus, here a plus. That value should be equal, okay, to exist the limit. Okay, the existence of the limit will be possible only when the LHL will be equal to RHL. Suppose let's take the one more example. Suppose I wanted to take one more example. Okay, suppose I am taking an example such that suppose this is a function here, and after that it breaks. Okay, it is being called as a piecewise function. Okay, so this is a point A and this is a function f. Okay, I wanted to find out the limit at a point A. Okay, suppose defining that this is f1 and this is f2. X less than or equal to A, the function is equal to f1, and x greater than a, the function is equal to f2. Okay, but when you find out the limit when you are approaching from the left hand side, the value will be totally different. Suppose this is a value y1, but when you move from the right hand side, you can see that this is a y2, and y1 is not equal to y2. It means that the limit is not existing and the continuity is also not there. Okay, LHL is equal to RHL when the function is actually approaching from the both sides and it will converge to a finite constant. Okay, I hope it is clear. Okay, if you face any doubt in between, just let me know. Okay, let's move forward and see this problem, because the basic understanding I wanted to give from the assignment 0 so that it can be helpful for the assignment 1, that I will take care of that in the next tutorial session. Okay, see this problem first, try to read it. After that I will give the solution for this. Okay, take your time and try to solve this. If you get the solution, write in the chat box so that I can relate that ki you are actually understanding the concepts. Okay, let me give the solution for this problem. So what it is saying that there is a function such that x tends to y, be an arbitrary function where the x and y belongs to a real number, and let a and b will be the subset of x. Is the following statement always true? It is saying that f a intersection of fb is a subset of f of a intersection b. Let's take it forward that suppose this is the x a set of some certain values. Suppose this is x1, x2, dot 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 xn, and there is a function which is being defined such that this is y and this is y1, y2, dot 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 and yn. Okay. So it is saying that there is a subset in between the x as well. Suppose I am taking the x2, x3. Let's take it as a subset. Suppose this is a subset A and this is a one subset as B. Okay. So A and B, A comma B is a subset of X. And what is saying that if FA intersection FB is a subset of FA intersection B or not. Okay. Let's take an example. Suppose let f is equal to x square. Okay, what is mean that y1 is equal to, when you keep the x1, that is x1 square, or y2 is equal to x2 square, or based upon that whatever the value you are giving. Okay, so and a is equal to -1. There is a element inside of the a, and the b subset is actually having one element as a 1. Okay, if you see that A intersection B is actually 5, there is a no element which is common in between the both sets. Okay. So what is the meaning of FA intersection B? FA intersection will be simply equal to 5 because there is no element. So there is no image of the A intersection B inside of the Y. Okay. So this is the important part. Okay, but I have told that taking one example here, that if it is f is equal to x square, y1 will be the x1 square, y2 is x2 square, and the element a, this subset a having one element considered as a -1, b equal to 1, a is equal a intersection b because the both elements are different in the both subsets, so it is 5, and the function of a intersection b will be the 5. Okay. So this is actually which we got from the LHL side, right hand side. Let's take from the left hand side. What is FA? FA will be equal to, because the function is actually x square, so FA will be equal to -1 of square is equal to 1. Okay. What will be the FB? FB is actually, if you see, there is a one element only, that is 1. So it is equal to 1 of square is equal to 1. So if you see that intersection between the FA in and FB is equal to 1, that is a one element is actually existing. Okay. So if you see that this FA intersection B is equal to 5 and FA intersection FB is equal to 1, it means that there is a one element in between the both can be belonging. Okay. So in between the FA and FB. But when you see that FA intersection B is actually a subset of this, means FA intersection B is subset of FA intersection FB, but not conversely. Conversely, if you see that it is not possible that FA intersection FB actually belonging to A intersection B. Why it is why it is there? Because when you are having the one element as 1, you can say that 1 and 5 is also can be there. That is no element which is possible in an empty set. Okay, empty set will be there, that is 5, and 1 will be also there. So it is saying that FA intersection B will be the subset of FA intersection FB. That is 5 can be possibilities there. So this question actually the solution of this is the false. Okay. So this can be very simplified by saying that considering a function arbitrarily. Okay. So here what we have done that there is a one set pre-image of y, that is x1, x2, x3, xn, and there is a image of x, that is the y1, y2, y3, and there is a function that is f which is governing this images. Okay. And what I have done that I have considered a function which is a very random, that is x square, and when you are giving a image that is x1, that is pre-image that x1, then the function will give the output as x1 square, and same with the x2. When you give the x2, the y2 will be the x2 square. What I have considered that ki A subset A having the one element that is minus 1 and subset B having one element that is 1. So in between the both the element there is no common term because one is minus 1, one is 1. Okay. So if you see that there is a F A intersection B is actually a phi because A intersection B is phi. So that is RHS. In the LHS, if you see, the FA is equal to minus 1 of a square because I have considered the element of A is minus 1. That will become 1. FB is equal to 1 of a square that is equal to 1. So FA intersection FB is equal to 1. It means that there is a one element is there inside of the FA intersection FB. So FA intersection FB is not a subset of FA intersection B. That is converse is there. Okay, the phi is there, so that's why it can be a subset inside of the 1. Okay, FA intersection FB. Okay, so the whole crux of this that key this statement is actually false. Okay, any doubt? Any doubt in this? Okay, let's move forward. Try to solve this problem. This is very important problem, and for this purpose I wanted to give few of the important concept into this. Okay, let's take your time and let me know if you face any doubt. Okay. Okay, let me give you few of the concept here. After that, you will be able to solve this very easily. So there's a few terminologies. One is the kind of concept of the disjoint sets. When you say that there is a sets that is A and B. A is having element 1, 2, 3, and B is having a 5, 7, 9 as a element. Okay, and this is the union of the set. Okay, when you see that there is no element in between the A and B is common. Okay, so that's why this is called a disjoint set, which is having no element in common in between the both sets. If you see the non-disjoint sets, in this there is a single element which is common. It can be more, but at least one element should be common in between the two sets. That is called a non-disjoint sets. Okay, so this is a concept of disjoint and non-disjoint sets basically. Okay, second concept here is the concept of few functions such that injective function one to one, surjective function, bijective function. Okay, when you see that key injective one to one function, it is meaning that if we are having a set, suppose this is a set which is having the element x1, this is having the element x2, x3 and x4. These are the four elements which is there in the set x. Okay, in the same set is function means having certain through some function having the output as a y. So this that one particular element is actually having the output one single output. Okay, so it is called as one to one. One to one means one input, one output. Okay, it is not will be there that key you are getting a two output from a single input, or single output is giving the multiple output. Okay, suppose let me take example. Suppose I'm taking an example that fx is equal to x square. That is function. So when you take the value of minus 1 and 1, you get the output both as 1. Okay, so this is not 1 to 1. Okay, you are having a 2 input and 1 output. Okay, that is actually called as surjective function. Surjective function is means onto function. Okay, so it means that you are having a two element which can have a single output. That is function of x square. When you are having the input as 1 and minus 1, they will give the same output as a 1. Okay. So that is called as a surjective function or the onto function. There is a one more function that is a bijective function, that is a 1 to 1 and onto both. It means that that single element having the single output, but it is possibility that the equal number of elements having the equal number of outputs. It means that no element should be empty here. Okay, but in the injective function, that is one to one function, it may be possibility that there is a output here which is not having a pre-image in x. Okay, that is a simple terminology that to understand that in injective function or one to one function you are having a single output from a single input, but it is possible that there can be output which don't having the input in the x. But in the surjective function there can be elements which are having the same output, but in one to one and onto, that is bijective function, you're having the single element and single output. There is no empty elements in the y which don't have any pre-image in the x. Okay. The second concept is that the image of a empty set. When you are having a b set, which is a means a subset of x, and if a intersection b is phi, it means that f a intersection b is equal to f phi and phi. Okay, so when the two sets, which is a subset of x having no element in between common, so their function also should not have any element. Okay, that is also an important concept. That, and it is not always true that f a intersection b does not equal to phi. Okay, it can be possibility that there is an empty set can be there in the function of a intersection b. Okay, got the point? So try to solve this after getting this concept. If you're facing any doubt, just let me know. Okay. Okay, let me give the solution for this problem. When you see that when it is saying that A and B are disjoint sets, disjoint set basically meaning that, and it is subset of X. Okay, suppose this is X is a plane and having the multiple elements, then there is a two sets, that is A and B, which don't have any element common. Okay, so it means that FA intersection of FB is actually equal to the phi. Okay, it is asking that f is an injective function. Injective function means one to one function, one to one function. Okay, that is actually true. Why I'm saying that? Suppose there is a function y and it is having a image y. Okay, x and y having a y having the pre-image as a and b, or a and b having the image in y. Okay, so it is meaning that fa, suppose x1, x2 will be there. So there is a one element which will be mapped through here. Suppose this is y1, y2. And here also x3, x4 will be there. So they will be mapped to the y3 and y4. But it will not will be the case that y1 and y2 will be equal to the y3 and y4. So they are actually a disjoint set in the output as well. Okay. So it means that f is an injective function when the FA and intersection FB is actually phi. So A option is correct, B is actually false. Okay. When you see the option C, when you see the option C, let me duplicate it. Okay. So if you see the option C, let me explain that. Let me explain that. C and D is a subset of X. Suppose X is there and C and D there is a subset such that FC intersection B is equal to a subset. It is asking that it is a superset of FC intersection FD. Okay. When you see that FC having some elements, FC intersection FD, okay, is a subset of FC this. So let's take the example. Suppose I'm taking that function fx is equal to x square. Okay. So when you see that there is a element that there is a function and this C having a subset here, that is, suppose I'm taking C dash, and D is having a image that is called as D dash. Okay. So D dash, that could be a possibility that FC intersection FD is actually equal to phi, which can be possibility that it is a subset of FC intersection D. Okay. That could be a possibility that C intersection D is actually when you see that FC intersection FD. Sorry, here let me take explain it better. Suppose FC intersection D is actually phi, so FC intersection FD is equal to phi basically, and FC intersection FD can be phi or can be any other value as well. Okay, so it means that it can be a superset, but not possibility that it is such that rule. But here it is given that it is phi. FA intersection FB is phi, so it means that this is actually a phi. Okay, but C intersection D can be phi, cannot be phi, so it can be a subset of that. Okay, equal also can be a subset also. Okay, so it means that this will not be the case, that is false, but C can be correct. Okay, Here also you can see that if it is an injective subset, that fc intersection fd will be a subset of fc intersection d. Okay, it is hold true when the function is injective function, one to one function basically. Let's solve this. Take your time and try to solve this problem. Let me explain this problem. When you read it, when you say that that x and y is actually a subset of a real number. Okay, and that f function, that is, suppose this is x and this is y, there is a function in between f, that is who's having the images in the y itself, and it is given that the b is a subset of y. It means that b is lying here and it is subset of y, and the function f inverse of b is actually b, okay, is only true when the f is a surjective function, okay. So let's remember that what we have learned previously, that what is one to one function, okay. One to one function is such that suppose this is x1, x2, x3 is there, so there will be one images of that y3, y4. X1, there's a one single image of a particular element in the x1 having the image y1, x2, y2, x3, y3. But it is possibility that one element cannot be having any pre-image in the x, okay. Similarly, when you see that onto function is such that two elements, suppose x1, x2, x3 is there, and here it is y1, y2, y3 is there, and the two elements can have a single output, okay. It means that key y1 is having true pre-images in the x, that is x1 and x2. But when you see that the surjective function, it is possibility that that x1, x2, x3, here y1, y2, y3, it will be 1 1 as well, and it will be also that it will be onto function, sorry, 1 1 onto function, yes. That it means that two element can be having a single output, but the thing is it should not be having any element vacant in y, okay, such that it is having a multiple pre-images, but it should not be inputting inside of the y, okay. Let's take it as example. Suppose there is a subset b in the y, b having a element x, y1, y2, y3, and this is the function x. Suppose this is x1, x2, x3, and this is function f, okay. When you say that function of x1 is equal to y1, because I'm considering that it is a surjective function, and f1 of x2 will be equal to y1, okay. So when you say that f inverse of y1 actually equal to x1, and here also f inverse of y1 also equal to x2. But when you say that f of f inverse of y1 will be equal to f of x1, f of f inverse of y1, sorry, x1 and x2, f of f inverse this x1, and here this is y1 and y1 will be function of x2. It means that y1, y2, this y1 is was the element of y, and the same element is coming, that is equal to the fx1 and fx2, because x1, x2 is a surjective function. So fx1 is already equal to y1, and this is also equal to y1, okay. So it means that this criteria, that function of for f inverse of b is equal to b, it is only true when it is a surjective function, okay. Because when you say that ki f inverse of y1 it is x1, f inverse of y1 is x2 also, but when you take that function itself, that f of f inverse of x1 and f of f inverse of x2, the both element output will be the y1 only, okay, if it is a surjective function, okay. And it should not be empty set in the x and y, so that's why there is a no element which is vacant, which can be possibility that it having a pre-image in that which is not being defined in that y, okay. So this is the important, and this is also a definition I have given that what is a surjective function. Basically that surjective function is such that each element, if you see here, having a pre-image in A, that is the A 1, 2, 3, 4, and it is a images at A, pre-images A, B, C, D. And the second, this is not the surjective function because there is a three element is which is empty. But if you see second part, that is also a possibility that it is also onto, means two input can have the single output. Okay, but it should not be empty here. Okay, so empty will not be there in the images side. So that's why a surjective function have a important point to remember, that key it is a onto function, and it is a function where every element in the codomain having a set possible output and at least one corresponding element in the domain, that set of the input values. In simpler term, you can say that the function covers the entire codomain, meaning there is a no element in the codomain that cannot be mapped to any element in the domain. Okay, okay. Let's move forward. Let's move to the fifth problem. Take your time and try to solve this. Okay, let me give the solution for this. In this question, it is saying that there is a function which is having x element and whose output is y, and such that g is such that y is having a z. Okay, there are two functions, and also a is actually a subset of z. If then it is asking that what is the f inverse of g inverse of a basically. Okay. So it means that when you are having a x set which is defined by a function f having a element y, and there it is defined with the g and is having z. Okay. So there is a criteria that suppose I am considering this is a LHS and output will be such that will be the RHS. Any of the value will be possibility. Suppose I am taking x is equal to f of inverse x1 basically f of inverse g of inverse of a. Okay, function of x1 will be equal to g inverse of a, or you can say that g of function of x1 is equal to a. Okay, so this is LHS. And let's take the elements like this. Suppose I am taking, if you are considering the first option, let me remove this. Suppose I'm taking A option. A option says that f of g basically, or you can write it simply like this: f of g of inverse is equal a. What is this value? So if the both functions are equal, it means that both are equal to the x1. Let's assume that it is equal to x1. It means that f of g of a is equal to, or you can say that simply, a is equal to f of g of x1. Getting my point? Because f of g you can take it at the other side, it will become a is equal to f of g of x1. So this is incorrect. Okay, because LHS is actually not equal to RHS. Let's take the other, f inverse of g inverse of a. So let's assume that it is x1. So it means that f inverse and g inverse of a is equal to x1, or you can say that a is equal to f of x1 then g of f of x1. Okay, but when you see that the values here, the g of f of x1 is equal to a, but here what is it is there, g of function of x1 is equal to a. Okay, are you getting my point? So it is possibility that it can be equal to both, but if you see the C option, g of f inverse, let's take here, g of f of inverse a is equal to x1. So it means that a is equal to g of f of x1. Getting my point? But here in the second option, if you see here, f inverse and g inverse, okay, of a. So it is not simply equal to the f of g of inverse. That is actually wrong. Okay. Here the thing is f inverse of g inverse is actually equal to a. It is saying that, which is not possible. So the option C is actually correct here. Okay. Here also if you see that f inverse g inverse a is equal to g of f of inverse of a, which we are aiming to prove. Suppose x is equal to this LHS side, it will be simply equal to f of x belongs to g inverse of a, or g of fx is equal to belongs to a. And here if you see the x belong to g of f of inverse, so So simply equal to g of fx is belonging to a. Okay. Let's move forward and try to solve this problem. Okay, let me give the solution for this. This is actually a triangular inequality. Triangular inequality. Okay. So it is saying that ki mod of a underscore b less than or equal to mod of a plus b less than or equal to mod of a underscore b here. Okay. So it is such that ki a and b is belonging to a real number. So let's assume that a is equal to 1 and b is equal to minus 1. Let's put the and let's see that what is actually happening. Okay, let's assume it's a option a. Option a will be such that a minus b, it will be 2. Okay, less than or equal to a plus b. A plus b is 0, less than or equal to a minus b, that is equal to 2. So it is actually false. So first option is discarded. Just take the option b. When you add both, it will become 0 here. Okay, let's let's add also, that is equal to 0, that is true. And here it is saying that is also uh, uh, a that is equal to a plus b, that is equal to 0. It's possibility that b is also correct. Okay, but a is wrong. Let's see c option. C option, when you subtract it, become 2 less than or equal to 0, less or equal to a plus b, that is 0. So it is false. Let's take the D option. D option is a plus b here. A plus b is 0. Less than or equal to 0. Less than or equal to 2. Okay. So here we are getting the two options which can be possibility that it is correct. Okay. Let's take any other options. Let's take the a is equal to 2 and b is also b is equal to 3. In the b option, when you take these values, it will simply become here a plus b, that is 5, less than or equal to a plus b, that is equal to 5, less than or equal to, when you add here also it will become 5. Okay, but when you see here in this option also, when you're taking the a plus b, that is 5, that is less than or equal to a plus b. What would be a plus b? It will be simply equal to 5. A less than or equal to a minus b, that is equal to minus 2. Okay, so this is false because it cannot be equal to the minus 2. It will become mod, that is becoming the plus 2. The but 5 is actually greater than 2. So the D option is also discarded. So B option is actually correct. Okay, so by putting the value, you can get the solution for the few of the problem. First, we have to make sure that you are very intuitive in taking the random guesses. Okay, let's take another question here. Let's take the 2 minutes and read the problem. After that, I will solve it. Okay, let me give the solution. So here in this question, if you read what it is saying that in a certain community, it is found that 60% of the all property owners oppose an increase in the property tax. It means that there is a community here, okay, and it is found that 60% of all property owners, okay. So there is two category there, which is a property owners. Second is non-property owners. Okay, so the property owners is actually 60% of all opposes. Okay, so out of all the property owners, 60% is such that which opposes. Okay, and 40% favors. Okay, what it is saying. While 80% of non-property owners, it means that 80% non-property owners favors. Suppose it is favoring, and here 20% is there which is opposing. Okay, so it is known as 60% of the community are the property owners. Okay, so this is 60% property owners, and non-property owners are actually 35%. So what is saying that what is probability? What is probability of selecting a random resident which favors tax increase? Okay, so it is saying that you have to guess the random person out of all the contexts to such that it will be favoring the tax. Okay, when you say that this is a part of favoring taxes, so this is a favoring taxes part. Okay, and this is also favoring tax. Suppose this is 1 simply, so it will be a 0.35 and this is 0.65. And what about this? This is zero point 0.8 times of 0.35 and this is zero point 0.2 times of 0.35. And what is this? This will be equal to 0.65 times of zero point 0.4 and here 0.65 times of zero point 0.6. So when you see the hierarchy says that what is the probability that randomly chosen residence of the community favors the tax increase? Favors means this part and this part. Okay, so just add these two values, that is simply equal to zero point 0.8 times of 0.35 plus 0.65 times of zero point 0.4. Let's solve. 0.8 times of 0.35 plus 0.65 times of zero point 0.4. It will be and it will be simply coming 0.454. So the probability is 0.54 for getting a random residence which community which favors the tax increase. Okay, what we have done, we have just segregated that there is a property owner and second is a non-property owners, and inside of the both community, that is property owner non-property owner, there are certain community inside of that which favors the tax increase and other is a which do not favors. Okay, let's move forward and try to solve this. Take your time and read the problem first. Okay, let me read the problem first. That is saying that given that a person's birthday is equally likely to be in any of the days of 365 days of the year, ignoring the leap year, the probability that the birthday of the 20 people will be different is equal to nearly equal to something. Okay. When you read the problem, it is saying that there are 365 days, and it is equally likely to get a birthday of that. So it means that there is a probability that 1 divided by 365, 1 365, 1 365 means the particular date the probability is actually same. It means that the probability of 1 plus probability of 2 plus dot 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 is equal to actually 1, and that is all the equal. Probability 1, probability 2, probability 3, all are equal. So it will be something 365 times of p of 1 equal to 1, that is equal to p1 is equal to p2 is equal to dot 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 p of 365 is equal to 1 upon 365 basically. Okay. So it is saying that 20 people which is having the different birthday, 20 people having different birthdays, it means that uh, uh, let's take forward that 20 people who are having the different, it means that getting the probability is 365 by 365 for a one particular person, and means for the rest people, and then 364 by 365 because the already one birthday is already being fixed, then dot 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 till the 24 person, that is a 356 by 365. Okay. So this is actually the probability of getting the 20 birthdays, simply 346 basically. And when you solve this, it will come out to be 0.588. Okay. So this is the probability of getting the 20 birthdays, which is totally different from the others. Okay. Let's move forward and try to solve this. If you read this problem, you will get few of the intuitive feeling that it is saying a fair coin, it is a fair coin, not a bias coin, is repeatedly tossed 200 times. Given that the toss outcomes are independent, the probability that the number of heads is equal to number of tails is, okay. It is saying that the probability of head and the probability of tail being is actually equal, and you already know that the probability of head getting a head and probability of tail will be equal to 1. So the probability head or the probability of getting the tail will be equal to zero point 0.5. Okay. So out of 200 times, if it is an equally likely system, so 100 times will come head. At which toss you don't know, but there will be 100 chances that you will get the head, and there will be 100 times that you will get the tail. Okay. So that is equal. So through the binomial dis- distribution, binomial probability, you can say that out of 200 chances, there are 100 chances that you will get the tail, and getting a tail is chances as a 100, and getting a head, it is equal to the 200 minus 100. That is simply equal to 200 c 100 0.5 means 0.25 times of 100. When you solve this, you will get the value that is equal to let me, no, because I have already solved, so I already having the solution. Let me give the final solution. It will come out to be 5.64 multiplied by 10 to the power minus 2. So 10 to the power minus 2 is already given, so the answer is 5.64. This is the correct answer. Okay. So here it is saying that you are having the equal chance of getting the head and tail. So probability of head is equal to probability tail, and the both summation is equal to 1. So equal likely, so it will probability will become 0.5, and out of overall 200 times, you will get 100 times as a head, 100 times as a tail. Okay. So binomial probability, you will get 200 c 100 0.5 power 100 and 0.5 power 200 minus 100, that is equal to 200 c 100 0.25 times of time power of 100, that is equal to 5.64 multiplied by 10 power minus 2. So answer is 5.64. Let's move forward and try to solve this. Okay, let me give the solution for this. When you say that the probability that a man hits a target on each firing is zero point 0.5, so means target hitting is actually zero point 0.5, target missing is actually zero point 0.5, because zero point 0.5 is the probability when the target is being hit, and probability of not hitting is actually zero point 0.5. So it is asking then what is the minimum number of times he must fire so that the probability of his hitting the target at least once is more than the, so at least once for hitting the target is actually greater than once is more than zero point 0.9. Okay, or you can say that not hitting a target or missing the target probability is actually equal to zero point 0.9. Let's take the threshold. Okay, greater than, you can say that probability of missing is actually equal to the 1 minus zero point 0.9, which will be simply will become zero point 0.1. And when you see that it is actually missing the target of all the times, suppose zero point 0.5 it missed, then zero point 0.5 it missed, zero point 0.5 again it missed, so all the times till the end times suppose it is facing, and after that it actually hit the target n times. So it means that zero point 0.5 to the power n, this is equal to zero point 0.1. When you take the log both sides, zero point 0.5, this is equal to log of zero point 0.1, and less than or equal to log of zero point 0.1 divided by log of zero point 0.5 log 1 log of zero point 0.1 divided by log of zero point 0.5. When you see, it will come out to be 3.32 basically. Okay, not, you can simply take the threshold basically like that. So it is simply equal to n is simply equal to 4. Okay, because you cannot target 3.3. Okay, it should be a integral multiple, that is 4. Okay, let's move to the last problem. After that we will end the session. Take your time, take 1-2 minutes to read the problem. After that I will give the solution. Okay, let me give the solution for this. So suppose there is a box. What is saying that there is a box, and in the box there is a green balls whose number is actually G, and there are yellow balls whose probability is Y, whose number is actually Y. So it is saying that the ball are removed randomly without replacing. It is very important that the ball is not being placed after the removing from the bucket. Okay. So it is asking the first green ball comes at k plus 1th ball. Okay, drawing at a k plus 1th times, you will get that the green ball. So when you start with the yellow and you will move to the k plus 1th times, first times to the k plus 1th times, you will get the green. Okay, let's see. So for getting the first yellow ball, the probability will be y divided by total, that is g plus y. And then when you are not replacing the ball, then the what the probability will be y minus 1 g plus y minus 1 dot, then y minus 2 g plus y minus 2 dot dot dot, where you are going till that last yellow ball will be there, y minus k minus 1 divided by g plus y minus k minus 1. Okay, and then getting the green ball, that is equal to g divided by g plus y minus k, that is the, because this is k minus 1, this will be the k. So this will be the overall probability of getting the green ball at the k plus 1th draw. Okay, because total box, if you see, there is a green G number of green balls and Y is the yellow balls. The total will be the G plus Y, so Y divided by G plus Y, and then multiplying by Y minus 1, G plus Y minus 1, then dot 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 going to the first green ball, that is G divided by G plus Y minus K. Okay. Okay, so this that's all for the today's tutorial session. If you have any doubt, we will discuss the tutorial next tutorial, the first assignment session, which will help to solve that. And before that, just practice few of the problems and you see the tutorial sessions and lectures. And if you face any doubt, we will discuss in the next tutorial session. Okay. Thank you.